Welcome back. I am Arup Basu from ClusterMicro Technologies. Today we are covering two topics that solve two very specific real-world problems in Java: exception handling. Okay, try with resources. So every time your code opens a file, a database connection, a network socket, or any other external resource, it must close that resource when it is done, even if an exception occurs. Okay. So before Java 7, ensuring this required repetitive try and finally code. So try with resources eliminates that repetitive try and finally code entirely and closes the resources automatically in the correct order even when exceptions occur. Now let us check the code on how these are implemented. Okay. So try with resources is a Java feature that was introduced in Java 7 that automatically closes resources used within a try block. Okay. So it eliminates the need for manual resources cleanup in a finally block, making the code very cleaner, safer, and less error prone. Okay. So resources are what? So resources are files, database connections, sockets, network connections, etc. that must be closed after use to free system resources and prevent leaks. Okay. Forgetting to close them or closing them incorrectly when exceptions occur is a common source of bugs. Okay, so try with resources guarantees that resources are closed automatically. Okay, even if an exception is thrown. So you can see the code here, right? So that code, it basically reads a file called test.txt, and when we run it, we get the output. Okay. So this code is a classic example of try with resources. Okay, so here is a breakdown of what is happening inside that code. We have resource declaration. Okay, the core of the code is that specific syntax. So we have try within bracket file reader fr equal to new file reader, then test.txt, and then we have buffer reader br is equal to new buffer reader fr. Okay, so in standard Java, when you open a file, you have to manually close it using dot close to prevent memory leaks. Okay, by putting these declarations inside the try parenthesis, Java treats them as auto-closeable. Okay, so automatic cleanup also happens as soon as the code leaves the try block, even if an error occurs. Okay, so Java automatically calls close on both BR and FR, that is the file reader and buffer reader references. Okay, so inside the block, the code performs a buffered read. Okay, so we have file reader. This is the file character by character. Then we have buffer reader. So this will wrap the file reader. Instead of reading one character at a time, it reads a large chunk of the file into memory, a buffer. So you can read entire lines at once using dot read line. Okay. And then we have the loop while line equal to br dot read line not equal to null, right? So it reads a line and assigns it to the variable line. If the line is not empty, that is null, it will print it. Okay. So once it reaches the end of the file, read line returns null and the loop stops. Okay. Then we have catch IO exception E block. It will act as a safety net. If the file path that is here, we have given C colon, then Java cert OTP, etc. is wrong, or if the file is logged by another program, the program won't crash. Okay. Instead, the exception is caught and the readable error message is printed to the error stream. Okay, system.err. Okay, so why this is good code? Okay, so before this syntax existed, programmers had to write a finally block and check if the reader was null before closing it. Okay, so the modern approach is it is much cleaner, and that is it is less repetitive code, then it's safer. You can't forget to close the file, and then readable, right? The focus remains on the logic of reading the file, not the mechanics of managing it. Okay. So the closing order is LIFO, LIFO, okay, last in, first out. The resource declared last is closed first, okay. The resources declared first is closed last, okay. So in our example, BR was declared second, right? So it is closed first, BR.close. And FR, the file reader reference, was declared first, it is closed second, FR.close, okay. So this order is deliberate and very correct. So closing happens even on exception. So this is the entire point with try with resources. Even if br.readline throws an IO exception, both br.close and fr.close are still called before the exception propagates. Okay, the resources are never leaked. So before Java 7, ensuring this required file reader fr equal to null, and like we have given here. So, and then we had to have a finally block if br not equal to null, try br dot close, etc., etc., right? So for a class to be usable in try with resources, there's a lot of extra code that we had to write, so which is not required for try with resources now. That's the point, okay? Now, how can you use try with resources, right? So for a class to be usable in try with resources, it has to implement java.lang.AutoCloseable, okay? This interface has one method. So public interface AutoCloseable, void close, throws exception, okay? Now, Closeable is the older interface in java.io. It extends auto-closable but narrows the close declaration to throw only IO exception, right? So all java.io classes implement closable and therefore also implement auto-closable. Okay, so database connections implement auto-closable through java.sql.connection. So auto-closable is very broad. It says I might throw any kind of checked exception, and closable is specific. Okay, so it says I promise to only throw IO exception. So this is helpful because when you use a file reader, you only need to catch IO exception. Okay, so you are not forced to catch a generic exception, which is generally considered bad practice. Okay. Now we move to suppressed exceptions. Okay. Okay, so this is an exam advanced topic. We have to understand it carefully, okay? So in the old way, that is pre-Java 7, if your try block failed and your finally block, which closed the file, also failed, the error from the finally block would win, okay? So it would be thrown up the stack and the original error that caused the crash would be erased from the stack trace, okay? So in try with resources, Java preserves the crime scene. That is by making the try block error the primary exception and attaching the close error as a suppressed exception, okay? So what happens if the try body throws an exception and closing a resource also throws an exception, right? Right? So there are two exceptions. So Java cannot propagate both simultaneously. The exception from the try body is the primary exception and it will propagate. And the exception from close is attached to it as a suppressed exception, accessible via primary exception dot get suppressed, okay? So we can access it like try within bracket throwable suppressed equal to primary exception dot get suppressed. The suppressed exception is not lost, okay? It is attached to the primary exception. This is specific to try with resources. In a regular try finally, if the finally throws an exception, it completely replaces the try block's exception, okay? The original exception is lost forever. Try with resources is better because neither exception is lost. So we have given a code example here for accessing the hidden errors, right? If we have to use like this, if we are to catch this in a real application. So first we have try my resource equal to new my resource throw new illegal state exception body error, say. Then you have a catch exception E and system.out.println. So you get the message, right? So it will print body error. Then we have for throwable T colon E dot get suppressed, then system.out.println suppress t.get message, okay? So it will also print the close error. So this is the way to get it, okay? So a few tips that variable declares in the resource section are effectively final, okay? So resources declared in the try parenthesis are implicitly final within the try block. You cannot reassign them inside the try body, okay? Like we have this code example here, try file reader fr new file reader and data.txt, then fr equal to new file reader, then other.txt, right? So it will lead to compile error because fr, the file reader reference, is effectively final. So you cannot assign anything else to it because it is final. So see you in the next video.